This is EJL Instructs Episode 2.
How does Blazor Desktop run your app's code? Is it sandboxed? Where does WebAssembly fit in? And more importantly, can Blazor format your hard drive? I'm Alon Lipton. Let's jump right in. To demonstrate how Blazor Desktop runs all of the code in your application, I've created a new project template using the .NET 6 Preview 5 version of .NET MAUI, and I've opened up the solution here in Visual Studio. Let's run the application so we can get an idea of what we're looking at. Here's a standard Blazor Desktop application. It's got a few tabs: Home, Counter, and Fetch Data. When we click on Counter, I can click on this counter, and every time I click, it increments the value by 1. However, if I switch away to a different tab and come back, the counter resets to 0 because this tab is reinstantiated with a blank slate, and I can increment it again, and every time I go back, it goes back to 0. So let's take a few steps and fix that problem. Now, to solve that problem, I'm going to use dependency injection with a singleton service that maintains the state of the counter. And I've done that over here in the startup.cs. I've defined a class called counterState that has the state of the counter and has the ability to increment the counter by an arbitrary amount, the default value of 1, and then invokes a change notification anytime that changes, the counter changes, so that we can refresh any UI that needs to update. All we have to do is, in the application builder, register that service as a singleton. So we've instantiated our service, registered as a singleton service, and we are off to the races. Now in the counter, I need to start making use of this. So my counter class is called counterState. So I'm going to use dependency injection to inject that into my page. So every time this page is instantiated, this component is instantiated, it gets an instance of the counterState object. To display the count, I'm going to use the counterState's count property. And we no longer need our own field to store that. So instead, we will go to counterstate.increment, and we will increment by the default value of 1. Now, this is enough to increment the counter and see the changes, but I also want to show how I can have different parts of the application modify the counter at different times and have them all interact with one another. So let's add a protected override void on initialized method. This is a method automatically called by Blazor when this component is first initialized. And so here we need to hook up the counter state. Let's see, what did I call it? It has a counter changed event. And I'm going to hook that up to the Blazor state has changed event. What this does is that every time the counter state raises its counter changed event, it's going to call Blazor's state has changed event, which causes all of the HTML in this page to re-render, and if there are any changes, it'll update on the rendered canvas. Let's run that now. Oh, we got a little build error. Can't convert methods to do a change. Oh, that is counter, not count. There we go. Some live action errors and fixing. Now that we've fixed our error, we can run our application again. And now we see, oh boy, the counter is jumping up by thousands at a time, but I can also click the button to increment by 1. So every 1 second, and we'll see how I did this, the counter increments by 1,000, so it's at 14, 15,000. And every time I click this button, it increments by 1. And those all interact together at the same time. So that we have a background counter that's a timer that's updating every second to increment by 1,000. And then I can click this button and increment on my own. Well, how do those interact with one another? Well, I skimmed over this earlier, but in my startup code, I've also instantiated a timer here that ticks every second. Every second that timer ticks, I'm going to call my counter state service and increment it by 1,000. That's why it was incrementing by 1,000, and I get that timer started. One thing to note here is that I have to call device.invoke on main thread async to ensure that this timer call executes its code on the main UI thread of the application. That's important in all UI applications, including Maui and Blazor, you have to make sure that all your code runs on the main UI thread. And this is how you do that. So we have here this background code that's running from what you might think of as the desktop or native part of the application that's updating the counters, calling stateService.increment. And then also in my Blazor code, we have other code, completely different code, that's also calling increment. The reason is that this counter state service is exactly the same instance no matter where you get it from, because all of the .NET code in this application, whether it's in a .razor file, whether it's in a .cs file, or anywhere else, whether it came from a library, NuGet package, you name it, it all runs in the same process, it all shares state. It's just that some of the code, the ones in the razor file, happen to render some HTML that gets pushed into a web view, and some of the code maybe runs on a background thread, and some of the code maybe renders native UI elements onto the screen. It's all one big application. It's just rendered a little differently in different parts of the app. Blazor Desktop, what an amazing technology. Of course it runs on desktops such as Windows and Mac machines. It runs on Android and iOS devices. But how does it actually run? Well, let's take a look at the different parts of a Blazor Desktop app. Here's what a typical desktop application might look like. It's got a menu bar, maybe some icons. And with Blazor Desktop, there's a new Blazor WebView control that renders some HTML. You might have one Blazor WebView. You might have many Blazor WebViews that you use throughout your application to render different parts of the UI. Many applications might even just have a single Blazor WebView that renders all of the UI. No matter what, it's a mixture of some HTML in the Blazor WebView and some native elements such as the caption or other parts of the UI of the app. That outer part is what we might think of as the native UI. And then this inner part is what we might think of as the web UI rendered as HTML and CSS. So where does all that code run? Well, your application code that's written in C# and .NET might include things such as class libraries. Those might be class libraries that you've written, or they might come from NuGet packages or libraries written elsewhere in your organization. Then you have your native UI code, which might be written using .NET MAUI, either using C# or XAML. It might be written using WPF, using C# or XAML, or it might be written using WinForms using C# or the designer, which itself also produces C# code. And you have Blazor components, which even though they contain HTML, it's actually all C# code that gets generated from Blazor components. So no matter how much HTML you have in a Blazor component, it's translated into C# statements that write out that HTML, and then later they get rendered somewhere. But that code still is C# and .NET code. All of that .NET code, all of those elements above, all run in one .NET process. All of it. So what about the web view that contains the Blazor part of the application? Well, this is what runs inside that web view. Of course, it renders the HTML and CSS that it is given. It runs any JavaScript code, such as custom script components. Now, most Blazor applications don't have a lot of handwritten or custom JavaScript because that's the whole idea of Blazor. You're using C# instead. But if you do have some components that are written using JavaScript, maybe a third-party component, such as the popular Bootstrap library, maybe you're using jQuery in the application, that JavaScript code runs inside that web view in that sandbox. And the last part is any code that interoperates between the web view and the rest of the .NET code. If you use the JS interop, JavaScript interop feature of Blazor, that can send commands between .NET and JavaScript. And Blazor WebView has its own inter-process communication, or IPC channel, that it can use to communicate messages back and forth between the WebView and .NET. That's it. There is no WebAssembly whatsoever in any typical scenario that runs in that WebView. Your Blazor code runs in this top part. It runs in the .NET process. You can run WebAssembly if you happen to write something by hand and translate it into WebAssembly and run that, but that is not a typical thing in a Blazor desktop application. Let's put it another way. We have three different ways to write Blazor applications: Blazor Server, Blazor WebAssembly, and the all-new Blazor Desktop. Let's compare a few scenarios. Where does the .NET code run? Well, in Blazor Server, it gets its name because it runs on the server. That would be running in ASP.NET Core. In Blazor WebAssembly, all of your C# code or .NET code is compiled and then transmitted and run through a WebAssembly runtime inside the client browser. And that has what's called a sandbox, which imposes some rules and limits on what your code can do. And then on Blazor Desktop, the code runs natively on the device, whether it's an Android phone or a Windows desktop computer. That code runs just like any other .NET code that runs directly on that device. What about the HTML that's generated by the application? So who generates that HTML? Well, in Blazor Server, you have server code that renders HTML and that gets transmitted to the browser. On Blazor WebAssembly, the WebAssembly code does that. It runs on the client in WebAssembly and renders their HTML. And on the Blazor Desktop, it's that .NET process because, as we mentioned, all of the .NET code runs in one process on the client machine. Where does it render into? Well, on Blazor Server and Blazor WebAssembly, of course, it renders to a browser. That could be any browser. It could be Safari, it could be Edge, it could be Chrome, whatever it might be. On Blazor Desktop, we use a different web view on each platform that is appropriate. So on Windows, we run the Edge WebView 2 control, and on iOS and Android, we run those devices' custom WebView. And of course, the question everybody is wondering about, can you format the hard drive from Blazor? Well, the answer might surprise you. On Blazor Server, yes, you can call code that formats the hard drive, but only the server's hard drive because that is where your .NET code is running. In Blazor WebAssembly, you cannot format the hard drive because you're running all the code as WebAssembly in the client browser sandbox, and fortunately, browsers do not have the ability to format the user's hard drive. On Blazor Desktop, yes, you can also format the hard drive. In fact, you can format the user's hard drive because that is the permission that you have when you're running native code. Just like you can from a console application using .NET, you can call the Format Hard Drive API of the operating system. Now, there might be other permissions that prevent you, if you're not an administrator, from actually formatting the hard drive, but is it technically possible? The answer is yes. You can format the hard drive.
This was episode 2 of EJL Instructs. Let me know your thoughts and comments below, or if there's any other topic you'd like me to cover. See you next time.